Okay, let's talk about different representations of functions, how we can represent them. We're mostly going to talk about linear relationships today, but you could do this with any functions. You can represent them in different ways. In this particular problem, let's change this color to blue. So let's start with coordinate pairs. This here is a function. If I graph it, I could graph this, and I would go to -3, 1, and graph that point. Sorry, that was on 3, 1. What am I thinking? All right, let's go to -3. There we go. I'm the math teacher here. -3, 1. And then -1, 5. Say it's up here. And then 1, 9 would be somewhere up here. And you could graph it. Okay, that's the function. Okay, it is linear because it does make a straight line. I could also put this in a table. So if I wanted to, I could put it in a table, an input-output table, and it looks like this. And I could determine the pattern that's happening in this problem. And what's happening is as my x's are going up by 2, my y's are increasing by 4. And from there, I could find the slope because we're going to do rise over run for slope. And remember that it's y's rise. So the change in y's goes on top in this fraction. So it would be 4 over 2, which simplified to be would be 2. So you can find the slope. That's the pattern that's happening. Okay, you could have also found that from the graph. And the other important piece you might want to find out is the y-intercept, or where it crosses the y-axis. And so to find the y-intercept, I need x to be 0. And you'll notice in this table, 0 comes right in the middle of -1 and 1. So if we find the number that comes between 5 and 7, that would give us the y-intercept. And so 7 falls between 5 and 9, and 7 falls right in between 5 and 9. So that's the y-intercept. So if I wanted to make an equation, we found the slope to be 2 and the y-intercept to be 7. And we could write an equation, y equals the slope is 2 multiplied by the independent variable and then adding the y-intercept. And that's how we would write the equation. So we could graph it. We could make a table. We have the coordinate pairs. They're all representations of a function. Okay, let's look at the input-output table. This kind of just takes it one step in because now we have the coordinate pairs already in an input-output table. And from there, again, we're going to determine how the x's are changing. They're increasing by 1. And how the y's are changing. They're decreasing by 4. And so to find the slope, I would do rise over run. And again, rise is how the y's are changing. It's y's rise. So it's how the y's are changing. They're changing by 4. And run is the x's, and it's increasing by 1. So you have a slope of -4. Okay. So if I wanted to, now I can find the y-intercept, and I can continue the table backwards. So if I continue the table backwards, instead of on the x's, instead of adding 1, I subtract 1, and I would end up at 1, keeping the pattern going. And again, on the other side, instead of subtracting 4, I would add 4, so it would be 1, 8. And then I have to get back to 0 because that's what will tell me what the y-intercept is when x is 0. So I'm going to just actually erase this x and y just to make some room here. And I'm going to go back to 0. So I subtract 1 again on the left-hand side, on the x side, and on the y side, I'm going to add 4 again, and it's going to be 12. That's my y-intercept. So if I were writing the equation of this line, I would do y equals, and the slope is -4, and then the y-intercept is 12, and so I would add it. And so this is the equation version of that function. This is the table version. If I wanted to do the points, I could just do 1, 8, 2, 4, etc. And I could list the points. I could also graph it. In the equation form, I could make an XY table, but the important thing to notice in the equation is this is my slope. It's with the independent variable, and that tells me how the pattern is moving. It's 2, so I would change it to 2 over 1. Whole numbers go over 1. And it's rise over run. So I know that as my x's increase, I'll put x here and y's here. As my x's increase by 1, my y's are increasing by 2. That's what's happening. My y-intercept is -4, and that's the starting point. So on my graph, it's where it crosses the y-axis. It's just my starting point. The y-intercept is my starting point. And then I would go up 2 over 1, up 2 over 1, and my line would look something like this. So again, graphing, representation of a function, the equation, I could make an XY table and do that. Now let's talk about a word problem, because word problem sometimes is what we get caught up on the most. So a word problem is, let's say for instance, I am buying a necklace. So let's say I'm buying a necklace and the necklace costs, let's say the chain itself costs $10 for the chain. And then I'm going to put beads on it, and the beads cost $3 each for the beads. And I want to know how many beads I can buy. So if I want to create an equation for this, I have a starting point. And my starting point is $10. Let me erase this because it's only one chain. So the 10 is something we buy. Sorry. The 10 is something we buy once. $10 chain. So when it's something we buy once, it's a one-time fee. I'm just going to add it like that. I paid $10. The beads are $3 each. Okay, when you see a number next to each, every, per, of, it means we're going to be doing some multiplication because we're multiplying it. However many beads I buy, that's what I would multiply it by. In this case, we don't know how many beads, so I would represent it by 3 times the number of beads. So if I take the cost of the necklace, let's take the cost of the necklace and add it to however much I pay in beads, that will give me the total cost for the whole necklace. And that's the equation I would write. And now from there, I can create a table. I could graph it, right? The y-intercept is 10. That's where I'm starting. I'm paying $10 without buying any beads. And then my slope is the number next to the variable, which is 3. So it'd be 3 over 1 because whole numbers always go over 1. So I would rise 3 and run 1. And that's how I would do that. And I could make an XY table if I wanted to do that. And that's how we represent functions, either by coordinate pairs, an equation, a graph, an input-output table, or a word problem. They can be represented in any of these forms.